So let's use my phone here as an example. So if you're looking, and let's say that we're going along, and this is my upper sieve. At the back right and the back left, above and below, there is an air intake. A single sensor here and a single sensor here. And all it's doing is measuring pressure differential, and that's how it's determining load. So there's an air intake and an air intake with a sensor here measuring the airflow that's coming off of the cleaning fan through our sieve. So let's say in this scenario we're going through, and on the right side we see a pressure differential. It displays in Pascal. 10 Pascal on the right side and 3 Pascal on the left side. What would that be a good indicator of? Right side heavy. Right side heavy, so if you're wondering how do we see that, run screen 5 comes on our 1200s. You can add it to a run screen on the Pro 700, but we have our indicator right here. So the whole thing and how it's determining what is our sieve load, how is it working, is just simply through pressure differential above and below the upper sieve, on the right and the left side on the tail end just before our loss sensor. After we're done here, if you don't know what I'm talking about and you want a visual, come find me and I can point it out to you. But on here, we can take it one step away and get back to your question. Well, how do I use this from just a setup standpoint, not even with automation, is another good thing I like to point out with this. So if we're running along, this is flat level ground, not side hill, because that'll throw all this kind of out the window. This is flat level, we're starting off. And we go back to IC10 and IC3 here. That was a good indicator of we're overloading the right side. So what would I do with these numbers? How is that helpful? Well, what about my sieve offset? So the nature of a single rotor is what all the time? It's right side heavy, right? Because our first threshing pass is that front right. That is the first threshing pass. So that's where all the material starts to build up, and then when it comes across the grain pan onto our upper sieve, it typically overloads it. So what you can do here is if we see that, and let's say we see this again 10 and this 3, we'll put an offset lowering our left side until these numbers are as close as possible. That way, how have we done the offsets in the past? Getting out, going, checking from behind, going and doing our offsets, coming back, running it again, and then seeing it and getting out by checking losses. This way, we can go ahead and we can balance it as close as possible from the cab and then get on to our final checks afterwards. But at least it saves us a few trips up and down the cab. Anyway, I kind of got a side note off of automation here. We're running back here, coming back to our overall, now that we know how is it determining sieve load and some of the background features of it, what is this telling us? So through the differential pressure, it's saying on this top mark, we are as loaded as we can without being overloaded, and this bottom mark is we are underloaded, the least amount of load with some level of efficiency. So in normal operation, ideally, you are above this mark and below this mark. Preferably what I like to see is as close as we can to this without overloading it and creating sieve loss, because why would I not put as much load on my sieve as I can? Because if I am underloading my sieve, I'm leaving what on the table? Capacity. Exactly, capacity. So we want to try and load the sieve as much as we can while having the least amount of losses. And this will be a good indicator. Now if you're running automation and it starts to see that it's overloading the sieve, adjustments will be made to correct that. But that is also a good tool that you can run with. On the 1200s, it's up all the time. 700s, it's only visible if you have it configured and automation is on. But it's a good indicator just to tell us where our sieve's at and if we're leaving capacity gains on the table.
So on that bar, is that the top sensor and the bottom sensor?
Well, so there's only two sensors. There's left and a right, and then there's a top and a bottom air intake. And you'll see the air intakes, those are visible from the inside, and then a blue line that goes into a sensor on either side. So this indicator here is simply an average of your right and the left, and then overall sieve load.
If you're going to do an offset, how big an offset?
Typically speaking, when we're doing these offsets, let's say we go back to that 10 and that 3, I like to do it at 0.1 of a degree at a time, maybe 0.2 if it's extreme, because we don't want to overdo the offset, because then all we're doing is transferring the problem of overloading the right to the left side and vice versa. So typically I like to do small increments at a time. That way we can get it the first try and then we don't overcorrect and have to come